Welcome to Gen.Struct.2 Lat.Forces, Lesson 3 quiz, question number 9, and it's us. It says, in the truss shown above, the stress in member A is, and then it's kind of a blank, and it gives you A, B, C, and D. And let's figure out what it is, and then we will, actually, let me do one quick thing. I know somebody made a comment saying that they would like you to figure out shortcuts to this answer. And I can at least, just off the top of my head, we could probably figure out if it's in tension or compression. So let's figure out what we know real quick. It looks like we have 2 tensions and 2 compressions. So we can cancel out 50%, and therefore you have a 50% shot of guessing A or C or B or D, depending on the compression or tension. So you at least have a 50-50 shot as opposed to a 25% shot, just going through one of 4, as you can do 1 of 2. So let's take a look. First things we know is, okay, you have a y component here, and you have a y component here only, and you have x component here. So if you have no x component, well, seemingly you have no x component, and this doesn't show you have a reaction right there. So you have no x component to resist that, and therefore this is a zero force member. This is a zero force member. So that's where you can start off, is this is a zero force member. So if you think about this, that's going to be compression. This is going to be compression right here. This is going to be, let's put C next to it. And this is, it's symmetrical, so I'm just going to do this side. I'm not going to go back over here and replicate it. There's no point. So this is going to be going into the joint, right? So it's going down right here into the joint, and it's going to be going into the joint up here, and therefore we're going to need A to go away from the joint, and therefore A will be in tension. So we can get rid of compression, B, and D. And at that point, if you're in a huge hurry and you just want to get a decent answer, you took the total of what, 10 seconds on this, and you pick one of those and you don't worry about it. Knowing me, I would pick A, because it's a round number, and hopefully they like round numbers. But since we do have the time, we're going to go ahead and solve this problem and figure out what that is. So first thing you need to do is you need to take a look at it like it's a free body diagram, and you need to figure out what your reactions are. I'm going to go ahead and label these joints because that's what I like to do. I'm going to call it A, and you know what? We're just going to call this A and B, and we'll call this C. Actually, let's do this. A, B, C, D, and E. And I'm not going to label anything else because we won't need to. We're only going to have to work with this joint to figure out what that load is. And on second thought, you don't even have to do that. You could just cut it like this. There's 2 ways you go about this, or 2 ways I would go about it. Method of joints or method of sections. A lot of people would just say, oh, do method of sections and call it good, which I have no problem with. That is a valid point. So let's not get ahead of ourselves. Let's get the reactions, because you definitely need those reactions. And you could go about and do the sum of the moments, and you could take, this moment, and all that stuff, or you can just realize that this is symmetrical. So you add up all your loads. You have 50. You're going to say, okay, this equals 25 kips, half of that, and this equals 25 kips. And I hope that makes sense to you by now. Hopefully that makes sense. It may not, and don't worry if it doesn't. Just go through the motions of what I would do is sum the moments about point A, and you would get a positive 10 times 12 foot plus 10 times 24 foot plus 10 times 36 foot, and so on. And then you take minus E, RE, let's call this reaction at E. This is going to be a reaction at A. And then you would divide that by this sum divided by 60. And if you don't, or divided by 72, if you don't get that, look back at the previous examples. And I didn't have my microphone plugged in, so it's a possibility that you can hear me better now, or maybe you can hear me the same. Let's find out. Anyways, I'm going to go ahead and move on. And so we found out what the reactions were. That's number 1 through your free body diagram. And now we want to go ahead and look at either the method of sections or the method of joints. And let's do it both ways. Why not? Some people, most people, would probably say, actually, let's go through the method of joints. Most people would probably just cut a section right here. But I'm going to go through the method of joints in a quick, brisk way, just because I appreciate that a lot. I like the method of joints because it's very thorough. And I happen to be a thorough person. So we want to assume that's coming out. We want to call this FAB. And you could do this a lot easier than what I'm doing. You could do kind of what we did earlier and say, oh, 25, and that's going to be 0. So this is going to be 25 kips in compression. But let's justify that and verify that by kind of doing the method of joints how I was taught at the Air Force Academy. And we say 25 kips up. We have FAC. And we have FAB. All right, so you look at this and say, well, the same thing we said up there earlier in this video and said, well, you have no other forces in the x direction. So your sum of forces, you could even write this out. Sum of forces in the x direction equals FA equals 0 or equals 0 equals FA. So FA equals 0. And we set that right here. That's how I denote a 0 force member. You just kind of put a not or a 0 over that. So FAC, sorry, I forgot that, equals 0. And similarly, we can say that, actually, now that we know, we'll just go ahead and switch it. But we could say, we'll go through the motions. Sum of the forces in the y direction equals 0. And then you say, okay, we have a positive 25 kips since it's going up. And then we have a positive FAB. And since you want to figure out, solve for FAB, you need to switch the 25 over to you have to subtract. Everybody knows how to do this. My wording is a little jacked up. It's algebra. You subtract 25 from this side, you subtract 25 from the 0 side, and you get FAB equals negative 25 kips. And when we get negative, you can get rid of the negative, or you can just say, oh, it's in compression, since we assumed tension. And therefore it goes down into the joint. And therefore you have, like we said earlier, going to be, you have it's going to be going into the joint. Remember, that's compression. And that's why you like to carry this C and T for compression and tension. So this is 25 kips. You have whoops. Not close enough. Good enough for government work. You have FBC, and then you have this FBD, it looks like. All right, and the angle is 45 degrees because you have 12 foot, 12 foot. It's going to be 45 degrees. All right, so what do we know? I'm going to go back to pink so we can differentiate the... No, we assumed that FBC was positive, or tension. So we have, this is going to be FBC, and I said FAC. It's going to be FAC in the y direction. And this right here is going to be FBC in the x direction. And you want to see what you can do you want to get rid of certain things. You want to isolate them, as I said in the past. And what do we know? We know we have 25 kips up. Okay, we know this doesn't have a y direction, so we can solve for the sum of the forces, because we have two unknowns in the x direction. We have FBD and we have FBCX. We only have one unknown in the y direction, so we want to sum the forces in the y direction equals 0, because of equilibrium, and you're going to have 25 kips up. And hopefully you can already see you don't have to write out these equations, given after a while you won't have to. And then we're going to have negative FBCY. Did I say y? Yes, that's because I meant FBCY. All right, so as you can see, you'll switch it over. FBCY equals 25 kips, and that's in tension. And you know, since we have 45 degree triangle, FBCX is going to equal 25 kips in tension. And from that, we'll take it over here And you can see that my guess earlier was wrong. It is actually 35.4. It's going to be 35.4. See, the components are FBCY and FBCX are both 25 kips. So essentially you have a triangle. Not essentially, you do have a triangle if you want to look at it. That looks like this. I'm just kind of blowing that triangle up right there. That now looks like this, 25 kips, 25 kips. And you could go through trig identities, or you can use the Pythagorean theorem, which is my personal preference. So I get my calculator out, and I'll go ahead and write this. This is what, FBC? All right, so you want to say FBC equals Pythagorean theorem is the square root of a side, the short side, the hypotenuse. Sorry. If you remember, A is the hypotenuse equals B, that's the side, plus C times the side. Or you can switch around by saying A equals the square root of B plus B squared plus C squared, which this is A, this is B, and this, no, sorry. I'm saying A is my hypotenuse. So your hypotenuse is A, B is a side, and C is a side. And you can go to Khan Academy if you need help on your trigonometry stuff. I will just assume that is known at this point. And if it's not, no big deal. Go to the Khan Academy, KhanAcademy.org, I believe, and look around, and it's a great site. So anyways, let's move on. 25 kips, or just 25 squared, plus, remember that they're in kips, 25 squared, and you get FBC is equal to, and at this point, using your skills in test taking, you notice that it can't be 25. You should know that, hey, 25 squared plus 25 squared and square root of that is not going to be 25. So you could have marked off A already and said, oh, it's C, which you could have done that, what, 3 minutes ago? I've gone on for 3 minutes longer than I knew the answer. And I also said, so there's your answer. And if you're fine with that, you can stop. What I'm also going to do, which I said I'd do earlier, is go ahead and do it with the method of sections. That's the method of joints, and that's probably how I would do it, just because, you know, maybe not. Because it's so close, I would do that. If we were out here in the middle, I would definitely, if this were A, I would definitely do the method of sections out there. But method of joints, I would have looked at this, said, oh, this is a zero force member, this is 25 up. I wouldn't have actually drawn the joints. I would have said, okay, this is 25 in compression. I would just put it on there just like I did. And then I would have gone up and said, okay, this only has X component, this has a Y component. I know it's a 45-degree angle, so I can say, I would have said right away, FBC X equals 25 kips. And I know since it's 45, 45, I would have said FBC Y equals 25. And I would have known the square root. That 25 plus, I would have known right now without doing the square root in my head, hey, it's not going to be 25, it's going to be closer to 35. Okay, 35.4, good, we're done. And that's how fast you could actually do that problem. So you wouldn't have to actually do the method of joints. It's just more of the thought process of going through the method of joints. And once again, sorry, I'm running low on time, but let's see if we can do this real quick. So there, let's do that. I like to put the points in here. It's D, C, and then we have what, 25? And we want to find, how am I doing on time? 1 minute. We want to find this member right here, so how could we? Actually, yeah, I would have done the method of joints, because and this is my 2-second opinion, and I may be incorrect, but from what I'm seeing, there's no way you can sum a moment to get this. I guess what you could do is you could sum, yeah, you could actually. You won't say, and I always look for summing of moments when I do method of sections. If you sum the moment, you can't get it because these are parallel, and you won't be able to. If you're looking for this member, you could just sum them around here because those two are concurrent, and you'd be fine. You'd get that. But in this case, you need to sum the forces in the y direction, and you will actually get the same answer because you can see you have 25, and then you're going to have, and that's going to be 25 right there. And that will give you that. This is 25, and therefore the square root of those. All right, there's your answer. I hope that helped.